Okay, so by now we should know that value parameter creates a copy of the string in memory. So let me see, string value, something like this, right? So if we create a string and we give it the value John, and we use the function loop string with index, which has a, or that has a value parameter John, we'll go there, and when we use this variable as a parameter here, then a copy will be created, meaning like it'll be in memory twice, okay, twice. And that's what's happening here. Like if we use John, then John, this string right here is a copy of this one, meaning it would be this guy over here. So why do I have all Z's there? Because we will change the value. We will say S equals Z. We will attempt to change the value to Z. So if we look at the diagram, this is the string we're working with. So JOHN should be overwritten with the values Z, 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 Z. However, anytime you loop with a for ranged, if this is not a reference, meaning you don't have the reference symbol here, then each character in string, a copy is created, maybe somewhere over here in memory. So we will be changing Z, the compiler will let us. However, we won't be changing the original or the copy, right? I guess the original copy. So we won't be changing this one. We will be changing some other character in memory. And we can show that that is the case by looping through this again, or maybe not looping, but we can say, well, see out the string. So what are we doing here? We're going to pass in a string. We're going to loop through the string with a for ranged. We will display the letter, and then we will say the character it is, change it to the letter Z. After the loop exits, we'll display the whole string to see if it changed or not. And I just told you it shouldn't change because we're looping by value. I guess for range by value. Which one's this? For ranged. 4, 4. Okay, so let's run that piece. Actually, we can't run it, right? We have to call the function. So let's go to main. Loop string with for range. Okay, let's use John since that's what we have on the diagram. Loop string with for ranged. Okay, that's the correct function. Come back to CMake and let's run that program. This one, for ranged. Run in terminal. And notice, oops, make this bigger. Okay, so we looped. We display one character at a time with a new line, JOHN. And we are attempting to change the characters to Z. And the compiler lets us here. However, look, when we display string down here, we haven't modified the value, which means that while it's looping, the letter J gets a memory slot here, so that's what we changed to Z. And then the loop exits J, this memory address is removed, and then when it loops again, the same address is maybe, right, probably so because the stack is sequential, is granted to O, and then to H, and then to N. So this is the value we are changing. We are not changing the value on the heap. And that's why we see John here, okay? While we're at this, let's create a test case for this. So the auto loop right? The outer loop, the for range loop is tricky, right? So you have to mind the references. Otherwise, you're going to get unexpected results. Test. So we have a string name equals John. Using string. And then we call the function loop for ranged. It's not here, right? No, it's not here. Okay, so include for ranged. Okay, so now we should have access to the function. Control space, loop string with for ranged, down arrow and tab, and it types it for you. And then you can say name. Okay. So our require statement will be that name is equal to John. Why? Because it's a value parameter, double equal sign, right? Value parameter meaning it's modifying a copy, so we should be okay. And we can run this test case. So, and then we'll go back to the example. So running terminal. And we are going over this because you'll see how important it is to understand call by value and call by reference. Like, it's not just for parameters, it's even in loops. So if it's a reference without const, then it's read write. If it's a const reference, it's read only. And if it's a value parameter, then it's a copy. We don't modify the original. So if you can remember those rules, then you shouldn't have any issues with this. So we're good, right? So up arrow space dash s enter. John equals John, so that's good for us. Let's go back to this code. Okay, what if we're like, okay, well now let's make this a reference, since you're stating that it was modifying a copy of the element or of each character. What will this do? Let's go back to the diagram. This reference loop will actually let us modify this copy now. Okay, so by adding the reference here in the for ranged block or header, then we can now say, well, give me access to these addresses. Oops, sorry, these addresses, and let me modify them. And we will show that by displaying the string. However, the test case should still pass because we are not modifying the original string. Which one is the original? This one right here. If we go and look at our test case, we structured it the same. We create name and we call the function, and then we're just asserting with the require statement. So let's see what happens. Running terminal. And notice here, let me make this larger. JOHN. So which code is that? So we are looping, but before we change the value, we are displaying the character. After we display, we change the character. Finally, after the loop, we say, okay, show me what the string is now. And that's this right here. So notice now it did let us change it to Z. which is this diagram. The copy was changed to Z, and our test case is still good. So let's see what happened. Up arrow, space, dash S, enter. And notice that it is still John because the original is not affected. Why? Because we passed in by value. And this can be confusing, right? Because it's kind of like, hey, wait a minute. You said value creates a copy. Well, it did create a copy, but then without the reference here, then it creates a copy of the copy. So you have to be careful with with situations like this. Okay, so let's create the same loop now. So we go back. So we'll create the same loop with a reference. So we will make this a reference, a reference, and we'll say underscore ref, like this. So now we are working with the original. That's what that means, right? So now let's like be lazy and rename it underscore ref. Make this a reference, and then we'll start with value. Okay, and we'll back to the diagram. We look for this. So this diagram is for a reference. So we create the string, it's granted memory, and it's on the heap, John. Okay, when we call the function also points to the same address, meaning it's now working with the original values. We are purposely looping with a 4-range loop without a reference here, and if it worked for by value, then it'll work here. What's that? It'll create a copy of each element on the stack, so we will not be modifying the original value. We'll be modifying elements that disappear after each iteration. They're just in memory while it's looping. Okay, so what will this value be if we pass in John as a string? It'd still be John, because this means create a copy of each character in string for each iteration. So the first loop, J is granted an address here, and we change it to Z, and it lets us change it, but then that goes out of memory, and the original element is not affected. The same thing will happen for JOH and N. So let's see. But before we do that, let's go ahead and build a test case. Test case, test string for range by reference. Let me put here param so we won't get confused. String name John, loop, down arrow, tab, name, and then we say, okay, let's set up our assertion with require. So name should be John, and let's see if that's the case. Run. And it's building. And it's taking this time. So we all know by now green makes you happy, right? Space -s enter, because it's the color of money and the color of test cases. Let's see here. Okay, that one. Test string for range by reference, and let me make this bigger to show everything. Okay, so JOHN, and then notice the value is still John, and our test case passes, which means even though we passed the original memory address for string by looping with a for ranged without the reference symbol, we are actually modifying a copy of each element. And if we change this to reference, now we will be modifying this addresses right here. So now we should see that this will be Z. And if I run the test case like this, with John here, the test case will fail. So let's see. Right, so Z John and JOHN Z, right? So references are actually important, right? This reference symbol is very powerful, and it can confuse us. But if you just remember any variable that has a reference, meaning like, oh, I'm accessing the variable's location. As long as it's not const, I can override it, and that's what we're doing here. Questions? Let me fix the test case. Here in auto? Well, yeah, well, this one gives us the original location, a reference. And if we go back to the value parameter, which is this code, a copy is created. So that's what this is showing. We have John, and then we use it in a function. You notice we have John twice here. We have John here and John here. Well, I X'd it out, but both of them have John because a copy is created. When we pass by reference, a copy is not created. Instead, the address of John is sent into the parameter. So now both of them point to John. And now we look at the code. If we do not have a reference, oops, not there. That's the value example. Let me go down here. Reference, meaning no copies created. We get the location of str in memory, but we're looping without reference. So now each time it loops, 4 times it'll loop, it creates a slot in memory. So J will be here, and then it'll be overwritten by Z, and then the loop is ready to go on to the next iteration. So that it's probably not erased, right? It's probably just overwritten. So then O comes here, and then we are overwriting O, so then O becomes Z, and then the same thing happens for the other values. So it loops the 3rd time. The value is H, and then we change it to Z. So who is doing that, or what code? This piece of code is doing that. So that's why these characters are not modified, because a copy is created of each character in each iteration on the stack. So we are modifying a copy of each element on the stack. Okay, so then maybe we should say, well, what if you show me that? And loop, so let me do it in main because it'll be clearer. Main underscore ref, and then we go ahead and run that one. Run. So let me see. Okay. Okay, so J, after we assign it, it's Z, right? And then O, after we assign it, it's Z. And then after we assign it, it's Z again. And then it's Z again. But notice when we say, okay, show me the string now. Let's go back and look at the code. Then it is still John, which means, oh, it's not modifying the original value, so this is happening, like what I was explaining. Why? Because we are looping with the for range without a reference here. And if we put a reference, then we should now be okay. Let me see. I think I need to put a new line there. Okay, and let me run it again. So notice now, after assign is still Z, 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 but now the final one, this statement right here, when we're like, okay, display the string for me. Now it's Z, which means with the reference, then it lets us access each element address on each iteration. So we are modifying the original value. Hope that made sense. I didn't make the rules, right? I just follow them. So, is that clear? Okay. Okay, so if we want our test case to pass, then we have to change those to Z's, and we can run our test case again, and now it should pass. I usually go over this example because the recommended loop for list and strings is a for range, but if somebody doesn't tell you about this, you probably waste like a whole day just wondering what the. So that's why I bring it up, right? Like it's one of those gotchas that can make you lose time, a lot of time, because you'll be staring at the code and it's like, well, I'm looping. Yeah, so this can waste a lot of time for you, right? So that's why I bring it up. Like if you didn't know about this and then you're looking at the code and it's kind of like, well, I mean, I'm looping and I'm assigning. Why is it not? And even here, I'm like, it tells me it's changing the value, but why? What's wrong, right? And so that's why I bring it up, because like somebody could be like, well, I'm passing by reference. Anywhere in the function, I can modify it. Well, you can, but if you use a for range, you have to make sure you loop by reference. And now we're all green. Up arrow space dash S enter. So notice we're good. Okay, so let me close this, and we will talk about vectors. So I did briefly just create a simple example in the last class for those who got that cookies question, how to create a vector. So let me for now just remove this. a vector, just like the string, is in the standard library, meaning you need an include statement. It's not here, it's probably in vector.h, I mean in vec.h, right, include vector. You need to help the compiler with namespace resolution, so then you can use the using stud vector. Once you do that, then you can use a vector. The main difference is from string and vector is with a vector you have to tell the compiler what kind of values you want to save in that list. In this case, I want to create a vector of integers and I want to name it numbers, nums. So that creates an empty list. In memory, just like the string, the vector elements will be stored on the heap and the stack will have a reference to that list. Behind the scenes, somebody created a lot of code for us to make it easy for us to create dynamic memory without even knowing we're creating dynamic memory. So just like the string, the vector creates dynamic memory and it's smart enough to know when we don't need that list anymore and it'll remove it from memory. We don't have to worry about removing it from memory. So they've done that for us, which is good, and I'm sure that's how the Python list works. Like they've done a lot of heavy lifting for you where you just create a list and then you start adding elements to the list. The biggest difference, the Python list allowed you to mix data types. You can't do that with a vector. Like you have to tell it like integer or double or a user-defined type. So if you say you're going to store integers, then you have to store integers. You can't mix. Okay, so nums.pushback is the function we use to add a value to the list. What values do I have here? 10, 3, 2, so I'll use those. 10, and then nums.pushback. Oh, nums. And nums.pushback. Is it 2? Forgot. You see, yeah, 10, 3, 2. So now this represents this diagram. We have a vector with the values 10, 3, and 2. And just like the string, we can query the size. So notice, like we can query the size. So the size here is 1, 2, 3. There's 3 elements. If we want to loop with a for range, not with a for range, with a traditional for, then we have to make sure we start the indexing at 0. And first element is 0, second is 1, and the third is 2. So always, the last one will always be size minus 1. And we go ahead and loop it. Well, actually, I didn't want to do that here. So usually I show this here, and then we go and create a function that uses this vector. Should I go through that? No, I'm not going to go through the same exercise that I did with strings, right? Where I show you that we can query it. I mean, if you really want to do that, then you can look at the code we used for string. Which code? Where we are asking it for the size and size of, and then you can just substitute the nums, that code, put it in here and put nums, and it'll still work, because the C++ committee wants all list structures or sequential structures to have the same functionality, more or less, right? So that developers can get very familiar with them. Okay, so we'll leave this one here. So this represents this diagram. We'll go through the same exercise we did with strings. So we'll create, so I'm not going to do that one. We'll do this one. We'll create a function loop vector with index by val. So then we say, okay, vector of integer nums. So again, this might be like, what? So that means it's a template class. We'll talk about that later in the course. For now, let's just say we have to do that for our code to work, okay? Okay, so right here, I'll write some code, and we just want to use a traditional for loop. So for size of ti equals 0, I less than nums dot size plus plus I, cout, we use subscript, so cout the value at nums of I, okay? Cout, I'm not sure if I have idle stream up here. Yeah, I do, okay. And this should loop through the vector. So if we come here and we put a microscope on the heap and we say, okay, it's here. So then it works like the string. This would be values 10, 3, and 2. Size 1, 2, 3, and for indexing 0, 1, 2. So notice the last element is always size minus 1. Okay, so that's why we have to set up the loop like we did, and it's the same thing we did for strings. So now this should be okay. Let's go to here, and now we can say okay. So and we use nums. And 4.6. Okay, so we run example 4.6 and run it. Okay, so 10, 3, 2, and the same concepts that work for a string work for the vector. Pass by value, meaning we get a copy. So if we modify each value to -1, we will be modifying a copy of the vector and not the original vector. So if we run this, and we'll create the test case right now too, notice it's still 10, 3, 2. We come back to the test case, and let's create a test case for that. So that one was VEC. Let me include that up here. VEC.h. Test case, test vector as value parameter. So this is the same thing that works for strings. Let me see here. I guess while I'm here, let me say using vector. Let me create a vector of integers, nums, but now I will create and initialize. This right here is an initializer list, so we can say 10, 3, 2. And this code also represents this diagram. We create a vector with values 10, 3, and 2. Okay, so here we create and assign nums. I'll name it nums. So now we say, okay, so loop vector with index val nums. It's by value, meaning a copy is created. So what will we do here, right? That's the question. So what goes here, and to make it easy for us and other programmers who might look at our test cases in the future or see our test cases, we can say the expected value, and then we say 10, 3, 2. So now we can say, okay, so nums should be whatever expected values is, right? So that's how we can help ourselves, right? In the future, we'll be like, oh, okay, so this is expected values. So I guess if I pass this into this function, then after the function executes, then this, I'm expecting them to still be equal, right? So, and we're self-documenting our code, right? We don't have to write comments. Just by the way we structure the test case, it should help us. So then let's see what happens. Run in terminal. And it's still linking. So we're good. Up arrow, space, dashes, enter. So notice 10, 3, 2. Okay. So that's good. Any questions here? So how is this in memory? So it would be like this, right? The values are different, but we have the vector. We call the function with nums as the parameter. A copy of the vector will be created. So we modified the copy and not the original. Okay. Same example that we did for integers and strings. Okay, so let's see. We go back to vec.h, and now let's do the same thing, but with a reference. A reference here. A reference. Copy this. And we can use this same code. So now what will the value be when we set up our test case? Test case, test vector as reference parameter. Vector, let me do this. So we create the expected values. We have the vector 10, 3, 2. We need to call the, I think I misnamed it. Let me correct it over here. It's not valref, it's just like this and like this. I'll remove one other one. Okay. Come back here. Yeah, so now it recognizes it. So is this test case okay or not? Anyone? Still waiting. So let me show you the code. So we have a reference, we loop, change the value. So is the test case set up correctly to pass? What do we need to change? So Joshua said no, so now I'm asking him, what do we need to change? In the test case. Anyone? They're the same in lines 78 and 79. Okay, what should they be then? No, the question is this test case set up correctly for a reference vector parameter? Will it pass? And we already know that it won't pass, so now that was Joshua's response, right? So now I'm asking what needs to change in this test case to pass this assertion. So we have this is a reference, right? So no copies created. And then in the code, we are doing this, assigning -1. So what do we need to do here to fix the test case? Yes. So now this should be okay. So now we come here and we run the test case. And building. And linking, taking a sweet time. And we're green, up arrow space dash s enter. Yeah, so we needed to change the expected values to -1. And again, this I was just making sure that students understood the reference piece. So let me see here, Joshua, Kimberly, and Jose. So you three send me an email that you answered this question, and then I'll grant you 5-point bonus on the midterm exam. But do it today before you forget, okay? Okay, so yeah, it was just to make sure that students were understanding what was going on, okay? So I wasn't trying to trick anyone. Okay, so our test case is good. Now we can go on and change this to cons for now. I'll change it back and then change this also to cons. So now it's a cons reference, just to demonstrate that once I make it const, I still have direct access to the original variable. However, I cannot modify it. It's already mad at me. And if I ignore it and still try to build, then I've shown you before that it crashes. The program won't build. So see, it won't build. We have errors. So I'll revert this code back. So remember, if you have cons, you're saying, yes, I want to give you direct access to the list. However, I'm not going to allow you to change anything. So any questions? Okay, and the same thing holds for looping with a for range, and we'll create that example too. So we'll say void loop vector with a for range loop, vector of integer nums. So that's by value. So a copy of the vector is created. And it's catching up. So we go down here. And we say for, notice I showed you on the last class that the for range is always your friend, because you can just say for auto num in nums, and behind the scenes C++ takes care of all the indexing and iteration and everything for you. Cout num. It is by value. So even if we try to change something here, it won't work. So again, if we go back and look at the diagram, not that I want to confuse you all, but this is what we have. We have nums, the variable created. We use it in a function as a value parameter. A copy is created. Purposely loop through it with a for range loop with no reference here. So meaning this won't be modified, this won't be modified either. Instead, each element will get their own memory space in each loop, and that'll be modified. And we showed that with the string, right? Where we're like, oh, okay, so actually with a vector we have to loop twice to show the values. I want to do that here. I'll just do that. I guess we'll leave a new line. So I don't know why I use, let me use -1 there. So if we try to change it, this will still be the original values, 10, 3, and 2, or 1, 4, and 10, whatever we use, right? Because we are looping by value with a for range, so it creates a copy of each element. And let's run this loop vector with for range. We'll run it in main, okay, because it'll be easier. Loop vector with for ranged nums. And what is it complaining about here? I think it's just catching up. So we go here and let's run the example. Run in terminal. So notice we have 10, 3, 2. That's the first loop. And we still try to change it. So this loop ran. Each loop iteration, we try to change the value. It changes the value, but it's a copy of the copy. And then we display the vector again, and notice it still has the same values. We'll also show that by simply making this a reference, now it'll let us change this guy, the copy, but this will still be okay, and we will prove that with a test case. But for now, let's go ahead and run the main piece again. So notice now 10, 3, 2 right here. 10, 3, 2, and now it let us modify this list. However, the first list would still be okay. And let's always prove with a test case, right? So let's say test case, test vector for ranged. So we'll use the same values here. Okay, so loop with for ranged nums, and this one's actually should be the same, right? So 10, 3, 2. And let's go ahead and run that test case. Don't be intimidated by the vector. This is as complicated as you'll get for us. Like, we'll create a vector, we'll use pushback to add values to the vector, and we'll use the for range to iterate the vector. We're not gonna get into like complicated stuff for vectors. Why? We will focus our lectures on object-oriented programming to learn the concepts of using classes in programs. Okay, so linking. And notice we're still green, up arrow space, dashes, enter. So the values are 10, 3, and 2. The test case will pass regardless of what we do here, just like we did for string. Why? Because the original vector is untouched. I mean, we can modify or not modify the copy. For the test case, it doesn't matter because the test case is checking if this guy changed, the nums vector. So we're still good. Up arrow space dash s, and notice it's still okay. Okay, so now we create another one. Loop for ranged, we say by ref here, so we'll say underscore ref. We come to the CPP. Okay, so loop vector with for ranged, and I need to make this a reference. I have to do this over here too, because we want to pass it by reference. So now we are not creating a copy. And we still want to loop. I guess that doesn't matter for now. And the same thing that we showed for string will hold here. We are passing by reference. However, we are looping with a for range and we don't have a reference here, so we will be modifying a copy of each element. So if we write a test case for this, test vector for ranged reference parameter, we can have the expected values and we can say a loop vector with the reference function and require nums equals expected values tab. Let me show you the code. This is the code we wrote. This is our test case. Is the test case written correctly? There's a list structure in C++, but the recommended list to use in C++, unless you have a specific reason not to, is the vector. And for what we do in class, we go with vector. So is this function set up correctly? Yeah, will it pass? Yep, it should pass. And let's prove it, right? So we run it. And building. And linking. And it passed. Why? Well, we're creating a copy here. I mean, not creating a copy, right? It's by reference. So we are using this diagram. However, in the loop, we're not adding a reference here. And when it's iterating, we're modifying a copy of the element. If we change this to a reference, then the original values are changed. These values are changed, which means we have to update our test case to make this one's -1, because that's what we are changing those values to, and our test case will pass. And it's building. What failed? Oh, 1. What happened here? Oh, that's my bad. My culpa. -1. Okay, so run, and it should pass. Let me do something over here quickly. Well, that one's building. And it's linking. All right. Okay, almost done here. So we're good, right? So I put a 1 here, so that's why my test case failed. So we're good, and hopefully these examples like clear up the value reference issue, right? So values copy, reference is original location, or you're dealing with the address of a variable. You can read write unless it's const. Let me go here. So that creates an empty vector. This creates a vector with 3 elements. Let me go here. Vectors, run it. Right, so 10, 3, 2, I'm looping twice in the function. So what does this do? Run in terminal. It creates a vector of 10 items of integer, and by default it initializes them to 0. Okay, so what does this do? 10, 10. So let's run it. So it creates 10 items in the vector, and it initializes all of them to 10. Okay, questions here? Like, this is just different ways you can initialize a vector. Right? For most of what you do, you can create an empty vector and push back, but if there's situations when you want to create a vector with some values, like for example in this case, right, for whatever reason we want to create 10 elements with the value 10. So this is how you would do it. What else? Let me think. Okay, so that's with integers. What if we want to say, well, let's create a vector of strings? So we're like, okay, vector of string names. We can start here, or as we can say, well, let's just say that we want it to start with Joe, Mary, and John. And how do we loop this? Well, for auto name and names, see out each name to screen, and we run it. Joe, Mary, and John. What if we're like, okay, so names of O override it, and then we go ahead and try to execute it. So we replaced Joe with Jerry, or we can replace Mary with Jane, right? Well, actually we need the subscript index here. Okay, what if we want a vector with that supports different values? Like how would we do that? Well, the vector won't let us, but we can have a workaround. We can create a class and create a vector of a user-defined type we create, and then we can work with, say that class has an integer and a double, then technically we can use an integer or a double anytime we're iterating through the vector, and we will show those examples when we get into objects classes next after spring break. So questions here, like